Deploying massive MIMO Open Radio Units ORU for 5G and beyond significantly enhances network capacity and coverage. However, the dense deployment of radio access network RAN infrastructure introduces a major challenge: energy consumption. To tackle the energy consumption concern, Viettel High Tech (VHT) introduces an energy-efficient massive MIMO ORU 30-T30 solution, which is O-RAN compliant and intelligently switching off partial radio to save energy. The VHT massive MIMO ORU has been tested at Singapore OTIC by Singapore University of Technology and Design SUTD and Keysight team. The time-sync analyzer TSA play a role of DU emulator, and multi-transceivers RF test set MTRX is used for cable test with multiple ports. Keysight DC power analyzer is used for energy measurement as well. Here is some photos of actual hardware setup. SUTD and Keysight team have validated ORU conformance test listed in the table during O-RAN PlugFest Fall 2024. Compared to predefined based beamforming method, which ODU only sends beam ID from a predefined set to ORU. The weight-based dynamic beamforming can adjust beam in real time to adapt to fast-changing conditions and track users dynamically, which we highlighted in the table. Let's introduce how Keysight tool can validate these test cases. The TS80U emulator can dynamically load test frames and beam weight, then encapsulate them within C-plane messages as an extended beam weights. The MTRX captures the radiated signal and validates the correctness of the beam configuration. Using Keysight O-RAN Test Suite, tester can easily load beam weight and observe the outcome beam pattern. Keysight vector signal analysis also provide different views of the signals, such as constellation, beam weight, and spectrum to complete O-RAN test cases. The measured 3D beam pattern aligns well with the simulated results, maintaining consistency from 0 azimuth to max azimuth beam weight. To verify energy efficiency features of the massive MIMO ORU from VHT, SUTD and Keysight conducted the energy measurement test using Keysight E-Plane Test Suite. The TS80U emulator generates different traffic loads, and DC power analyzer provides power and measures power consumption of the ORU. MTRX measures radio output power. The energy savings algorithm can work in a time slot level, and the newer version in the symbol level. As shown in this animation, VHT introduces energy savings mechanism in symbol level to turn off power amplifier PA in RU. Using Keysight automation platform, users can execute different traffic load tests with user-defined test durations. Test reports are automatically generated after completing the test. For low loads, only the resources elements dedicated to PBCH, PSS, SSS, and DMRS are transmitted. Keysight Vector Signal Analyzer is used to verify signal spectrum, timing signal, allocated PRB, channel power, and decoded bits. For medium loads, 30% of PRB dedicated to PDCCH and PDSCH were transmitted. For busy loads, all resources elements dedicated to PVCH, PSS, SSS, and DMRS were transmitted. 50% of PRB dedicated to PDCCH and PDSCH were transmitted. For full loads, all resources blocks were transmitted. At Singapore OTIC Lab, the energy efficiency mechanism of VHT ORU at slot level has been verified and achieved up to 48% of power saving. A newer version of energy efficiency algorithm at symbol level has been tested at Viettel Lab and achieved up to 57% of power saving. The energy efficient algorithm of VHT massive MIMO ORU has demonstrated exceptional effectiveness in saving energy. Throughout this demo, SUTD Asia and Pacific, OTIC in Singapore, has successfully showcased its capability to test and validate O-RAN compliant massive MIMO beamforming and energy saving feature.